Hey everyone, this is day 2 of Hacktoberfest. And I should probably get some GitHub hacking going on as well, but right now we're on Leetcode and the second task should be up. It's called combination sum. I've never seen it yet. I'm not much of an algo person, so this is the raw footage of me thinking about it. Let's just set up my project. Why is this? I was testing some stuff. Let's create my file 2.kt and let's go. Given an array of distinct integer candidates and a target integer target, candidates and targets, return a list of all unique combinations of candidates where the chosen number sum to target. You may return the combinations in any order. So we need unique combinations, return a list of all unique combinations. Okay. The same number may be chosen from candidates an unlimited number of times. This is a very important one. I think I have done a similar task where you could not use the same number multiple times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. Okay, fair enough. Candidates. Ugh, this sounds like there will be some dynamic programming going on there that can do it, but my initial greedy approach would be just go through the numbers and then on every possible step take the number and don't take the number and split my decision tree in two. Let's see if I can explain it better. So if we go with this approach, if we have 2, 3, 6, 7 and my target is 7, then I can do a decision. I'm starting with nothing, I'm starting with 0. And then starting with 0, I can either take the 2 or branch out and not take the 2. Then from here, I have 2. Now I can again either take the 2, resulting in a 4, not take the 2, resulting in staying at the 2, and then at the 0 I can take the 2, and then I can not take the 2. And immediately I have something that maybe should be cached, because I already, by now, I should know what happens when I have a 2. So it would be redundant to calculate it here as well. But for the sake of I'm basically drawing a graph, but instead of drawing it downwards, I'm drawing it to the right, since it's easier for me to write it this way. And again, here I can either add a 2, so this is a 6, or I can not add a 2, so this stays as a 4. And here again, I can either add a 2, so this becomes a 4, or I can not add a 2, so this stays a 2. Here I can either add a 2, so it becomes a 4, or I can not add a 2, so it stays a 2. And here I can add a 2, or I can skip adding a 2. And now I'm almost there. So one last time, here I can no longer add a 2. So here, I'm not sure if these are always ordered. I think they are not guaranteed to be ordered. So imagine there could have been a 1 somewhere, but here I'm gonna say I cannot add a 2. So try to add a 3, I cannot add a 3, try to add a 6, I cannot add a 6, try to add a 7, I cannot add a 7. So this branch is impossible to find a solution with. But I think my current approach is not working, because actually all of my branches will end up at a 6. And what I really want is, oh, wait, when I am not adding the 2, I can add the next one. But still, I want to be able to have a path where I don't add anything until the last one. So maybe I can either add the 2 or not add the 2. On the next step, I can either add the 3 or not add the 3. And on the next step, I can either add the 6 or not add the 6. And then on the next step, I can either add the 7 or not add the 7. See, this, yeah, this was a bit easier when I remember it, when you don't have duplicates, because I would either just add the 2 or not add the 2, and then I'm on the next index. But now I'm supposed to be capable of adding the same number multiple times. So maybe when I add it, I stay on the same index, and then I can either again add or not add. And when I'm not adding, I move index. I move indices. I think this would work. So let's try something very quickly. So I either add the 2 or I don't. So I have 2 and 0. Then here, I'm already looking at index 3. Index 1, the number 3. But here again, I can either add the 2 for 4 or not add the 2. And then I branch out to index 3, but staying as a 2. And here I'm already on index 3, so I either add the 3 or I don't add the 3. I'm gonna add like some symbol when I'm moving, so that I don't forget. So here I can either add the 2, I become the 6, or I cannot add the 2, so I become I keep as a 4, but I'm gonna be moving indices. And then here the 2, I either can add the 3 because I'm already on. I should just have the index where I am, because this is gonna get more complicated otherwise. So this will go to index 2. And here I either add the 3, so I become a 5, and I'm still at index 1. Or I move to the next one, to the 6, so I keep as a 2 and I'm on the next index. And here the 3 can either add it again, so it's a 6 and I'm still on index 1. Or I can not add the 3 and then I can move to the 6, so I'm on index 2. So I'm keeping as a 3, but I'm on index 2. And finally on this 0, my god, so much spacing, so hard. On the 0, I can either add the 6 and keep on index 2, or I can stay as a 0 and go to index 3, where I'll get the 7 solution eventually. Okay, I think this makes sense. I think this will bring me solutions, because before that I was just stuck. Oh, so this actually looks more like the knapsack problem. Was it the knapsack? No, the knapsack was when you were putting things in a bag. It was about putting as many things as possible. Here we need an exact count. Okay. So we have some constraints. Candidate's length, so we don't have to check for null or empty, since we're guaranteed to have at least one item. Their values are up to 200. All elements are distinct. This is interesting. I don't think it matters really for our algorithm. Let's just try the brute force approach and then see if we can speed it up somehow. So I'm gonna grab this boilerplate here, maybe like that, to make it easier. Why is this red? Okay, it's not returning anything. Okay, great. So I guess I can write some sort of a recursive function to do that, and then I'll probably think about catching the recursive function. So just like that, and see what happens. In order to achieve this, I need the list of items, I need an index, and I guess that's it. And then on every index, I either take or I don't take. And when I take, I stay on the same index, otherwise I move to the next one. Oh, and every answer is just a list of itself. So it's a list of lists. Okay, great. So I have a mutable file answer is a mutable list of mutable list of int. So then I'm gonna call my rec function with candidates. Well, I guess I need a target as well. Target index, which is 0, and answer. I'm gonna say return answer. It should be something like that. So let's go ahead and add parameters. I actually like doing this, so actually I can see what's going on. So my recursive function, what's the bottom of my recursive function? So I'm always attempting to both add the current element once and go to the next element. And if I cannot add, then I just go to the next element. So do I actually need to keep my current sum? I might need to keep current elements that are being used. Oh god. Where I keep the current elements in the answer array, but then I have to traverse the answer array every time. I'm actually in these kind of situations that I prefer to have some helper date structures. So let's say I have a class called sum sum, and in that data class I'll have a mutable val elements, which is a mutable list of int, and then I'll have the sum cached, so it's a var sum, so that I can modify it, which is of type int. Do I need anything else? I might even keep the index here, like where this is heading, so I can have like index var index, which is int again. So in this recursive function I can just have a mutable list of these comp sums. Right? Or I can keep it as like this, but I can just pass my comp sum like where I'm starting from and then split them. So I'll just pass a comp sum with I guess I can even have default values like 0 and 0 and mutable stuff. So this should work like that. Now I don't need index, since it's in the comp sum, and then I'll do my bottom is if this will be a CS. If CS dot sum plus candidates of CS index is bigger than target, or if it's equal to target, it's actually the good one. If it's equal to target, then I'll just say answer add mutable CS dot no. Let's say CS dot elements add candidates CS index. Well, I don't always add it though, do I? I sometimes don't add it, never mind. So if this happens, then I'm just gonna say CS dot candidate elements add candidate CS index, and then answer add CS elements. So this is an answer, and it's a reg answer. And I am done with this one. So I just return if CS sum plus candidates CS index is bigger than target, then I'm not gonna be adding anything. I'm just moving to the next element. So I'm just gonna call a rec with I also need my index to be smaller though. It's bigger than target. I guess I can have this as a prerequisite here. If cs.index is equal to candidate's length size, then just return, because like this is not longer solution possible. If we didn't get this one and we're getting out of bound, so it should be even here, so we guarantee we're not out of bound on this check. Okay, so if it's bigger than target, then we just move to the next one, since they're not ordered, right? Yeah, they're not ordered. So I'm just gonna call rec with same candidates, same target, same answer, and I'm moving the index. So I need to move the index. cs.index plus equals to 1, and then just pass it on. So if it's bigger than target, and if it's smaller than target, we need to do both. So here we checked the index, it's fine. We checked equality, we checked bigger than. If it's not bigger than, it means it's smaller than, since we have everything else covered. And then if it's smaller than, we'll do both. We'll do rec with I'm just gonna clone this. So cs2 val cs2 equals cs.copy, and the copy will have the same. This is where I'm not adding it and moving to the next element, so it will have the same I need to deep clone the list, the elements though. If I call to mutable list, is it gonna be copied? Return array list this. Is there some other kind of copying? I just want to make sure that I'm deep copying. This is a Java function, isn't it? Java to array list. And this is a new array list where we pass this. And in the Java, when we pass this, what happens? When we pass a collection, this is the one. If it's not 0, it's not object. So this is one arrays copy of. Okay, so there is an arrays copy of. Okay, so I think this should be fine. So I'm passing this. I'm passing the sum, but I'm passing also cs.index plus 1. Whatever. Fine. So this is my, I copied it already, so I can move, I can mutate the original one. where I'm gonna keep the index the same, but I'm gonna say cs.sum plus equals candidates CS index and cs.elements add candidates CS index, and then I'm gonna call rec with both. So candidates, target, answer, CS, and CS2. So it was important to do the copy first, so that we didn't mutate this thing yet. And if everything goes well, this should be super slow. We should be caching something somewhere, but this should kind of work. So can we like test it? Method is combination sum. Candidates are int array of 2, 3, 6, 7. Target is 7. And do we return? Yeah, return the answer. So I'm just gonna go and for each. So I'm gonna have a print ln here, and then I'll say it for each. It print it, and I'll print. This is in element. Print L. I'll do it like that. L. That should be good. So let's see. Infinite recursion or solution? Two to 3 and a 7. Okay, let's try the other one. 2, 3, 5 and an 8. 2 to 2, 2 to 3, 3, 5. 1 and a 1. And then 1 and a 2. This works. I think it's gonna work also. Great. So let's give it that and see how slow we are on the bigger one, on the bigger ones. Wrong answer. Huh. Well, at least it gives us the input. So this is one where they are not ordered, which was my initial concern. 4 to 8. I mean, I can always just order them, but I don't want to do that. Hope preferably. So I give 4, 4. I give 2 to 2. I give the 8, but I don't give the 2 to 4. Why don't I give the 2 to 4? I should be able to have a 4 and then move next, and then 4 and a 2, which is a 6. And then for that 6, I should be able to do again add a 2 to the 6 again. I mean, that's exactly the case that I was trying to make sure I'm not avoiding. So I should be able. It's just not gonna be 2 to 4. It's gonna be 4 to 2 in my case. It should be, but it's not. So let's see. We're at a situation where we have a 4, and then we move here. So they're not bigger than target. So we have a 4 and 4, and then we get into this one. So we have elements in some 4. We have some 4. And we're on index 1. So we copy, then we say sum plus equals the 2. So we have 4 and a 2. So this is a 6. And we are adding the 2. So we have 4 and a 2. And then we call with this one. So we have 4 and a 2. And we're going again into recursion. 4 and a 2. And index is 1. This will not break. It's not target. It's not bigger than target. So here again, we make copy again. So we should be able to say for and a 2 and a 2 here. And 4 and a 2 and a 2. So this is an 8. It's 4 and 2 and a 2. And we call it again with this one. So we should be here, where index is still 1. So this is okay. Wait, 4 and a 2 and a 2. Already here, like I have a 4 and a 2. This is the 6, and I'm going here. And here I have 6 plus 2, which is 8. So this should be adding an answer. Am I overriding answers somehow? Should I just go again to mutable list here? No, not overriding answers. Can I have a breakpoint here when sum is 4? Can I have multiple? Oh yeah, I can have. So it equals 4 and CS index equals 1. This should be it. And run. I have the 2 and 2. Oh wait, I actually want it to be 6, not 4. Again, it's gonna stop on 2 and 2 and 2. That's fine. And it's gonna sum 6, index 1. Oh, index 1. Okay, index 1 is not gonna be a solution. Index 0 should be the solution, but we already have it. We know that. Wait. Sum 6, index 1. Oh, I have index 1 as a prerequisite, didn't I? So I never have a 4 and a 2 and a 2. A 4 and a 2 I never have here with index 1. Why is that? Wow. 6, 1. Can I just see every time index is 1? We have nothing. Sum 0, index 1. We have a 2. Sum 2. Index 1. 2 and a 2, index 1. 2 and a 2 and a 2, index 1. We never have a situation where we have a 4 and we're on index 1. So where do we add the 4? I'm missing one case somewhere. I'm not splitting properly. So when I have a 4, when I add the 4, I should also be adding the other one. Do I need to split it in three places here? This is insanity. So I both add it and I don't add it. If I don't add it, I mean if I add the element, I'm not moving. But then I do it again and I'm not moving and I get the double force. So this is like I never get the 4 to move to the 2 since I can add both 4s and then it's done here. So actually, if it is target, I do add the answers. I am done with the current iteration, but I can also say I'm not done. I can also say I can do like this. If I'm supposed to be done, I do this, where I copy it. Don't need this. I copy it with the exact same sum and the next index, and I just do again rec with candidates, target, answer, and CS2. I hope I didn't do an endless recursion here. Wait, maybe if I don't do this, but I also don't return, am I gonna change anything? Why did I suddenly fuck up? I'm adding literally one extra element every time. So this is the base case where it works. But it's missing an element. So I think if I sort them, this never happens, but I don't want to have to sort them. So I need to somehow go in the case where I add 4, and then I'm presented with the opportunity to add another 4. So this is where I am. I'm at index 0. I have a 4. 4 plus 4 is 8. I want to consider it an answer and also carry it over. So both. I want to do both. Index plus 1. Well, this is what I want to do. Why does it work? Maybe I do this and then I code a rec with everything. But I still return afterwards. For 4, 4 to 2, 2 to 2, 8. It's in different order, but I think this is my solution. I mean, this is gonna fix the problem. I can just just change this. So I just have to keep the return, because otherwise I'm getting in these conditions. So let's try this one. Yay, accepted. Combination sum. I'm pretty sure there is a very well-known algorithm for this. But I hope like watching me struggle through it gives you more confidence in yourself. Since it sure feels, I mean, I love watching competitive programmers solve algorithms, but you have to remember that this is what these guys do every day, and most of the problems are very similar. So after you've completed like 1,000 problems, you're not gonna be surprised. Like every time you see a new problem, it's gonna be a subset of a problem that or a superset of a problem that you've already done at least 10 times. So you'll be able to be much faster. And even I have seen similar problems, so I had some idea how to approach it, but I've seen it like 2 years ago, and I don't want to be making excuses. I'm just happy I managed to solve it in about 30 minutes, even a bit more. And it's not optimal for sure. This is not the optimal solution. Actually, what is the runtime of my solution? Is it squared or even more? So every time I'm either taking or I'm not taking. And if it's sum, I just do the same actually. If it's a sum, if it's a sum, I both take it as an answer and then I don't take it. And this can probably be extracted somehow. This logic and this logic are kind of similar, so it might be possible to extract them somehow. Maybe I can have this as a top level, then it doesn't really matter. Okay, cool. But yeah, what I meant to say is that it's okay to struggle. The first time I was solving similar problem, I miserably failed and had to look up some solutions. That was like some years ago. Now I have some more idea, but still not that good at those problems. But just thinking about it helps a lot. And I guess this should not be in the video. It's just the struggle part should be in the video, and maybe I can come up with a different ending. Whatever. Just happy that I managed to complete the task. Okay. Well, a very small thought about if it can be dynamically programming solved. So I have a target. After taking every candidate a certain amount of times, target is smaller. So can I have like a two-dimensional array, like a candidate and how many times I took it, and how much of the target is left? So if I have this kind of a table, why don't I have Excel here? How is it called? Calc. LibreOffice Calc. Yeah, it's called Calc. Okay, so if I have a two-dimensional array like that, what? I just wanted a border. Come on. And I have candidates, like I have 2, I have 3, and I have 6, and I have 7. Can those be smaller? So this is my y coordinate, and then I have number of times. So here I have taken 0 times, taken once, taken twice, taken 3 times, taken 4 times, as many times as I have to. Like maybe as many up to target, since minimum always 1. So if target is 7, I'll just have 7 rows. 5, 6, 7. Since I can 8 rows, since I can take 7 times a 1 if I had a 1, and it's a valid solution. Can I fill this table somehow to make sense? So if I take 0 times 2, then my target is 7. But how do I do the combinations between 2 and 3, for example? I'm just gonna think about it for a second. Is there a pause button? There has to be a pause button. Come on. Pause. Nope, there is just stop recording. Okay, whatever. Stop recording.